Our mission today is all about pure, fascinating discovery. We've got three, well, pretty surprising nuggets from recent sources that show how technology is quietly reshaping everything around us, our cities, our cars, and even, how we think about intelligence itself.
It's a really eclectic mix, isn't it? We're jumping from underground physics to wild automotive engineering and then right into the limits of AI. It seems all over the place.
It does.
But the goal here is that by the end of this, you'll have some really quick, comprehensive insights into what's happening in these, well, pretty game-changing areas.
Okay, let's unpack this first one. We're starting underground. The company Orange is working with Veolia to give their fiber optic cables a sort of secret superpower.
Mm-hmm.
They're using them to detect underground water leaks. It sounds, I don't know, a little bit like a comic book premise, but the thinking behind it is just so smart.
It's brilliant, and it's all based on a principle called fiber sensing. Most of us just think of these cables as, pipes for data, A to B.
Right, for your internet.
Exactly. But the fiber itself is an incredibly sensitive instrument. So what they do is they're constantly shooting a laser light down the buried fiber.
And as that light travels?
Well, the tiny, tiny fraction of it naturally scatters and reflects back. They call it rebrousse-chemin, which just means turning back. But the crucial part is, as it travels, that light picks up a memory of every single vibration it encounters.
Every tremor in the ground.
Every single one. It's like an invisible magnetic tape just constantly recording the ground activity above it.
That's a powerful way to put it. But the ground is always vibrating, isn't it? You've got traffic, construction. How do you separate the tiny sound of a leak from all of that noise?
And that is the big technological leap. It's in the equipment from partners like VIAV Solutions and Lightsonic. They're the ones who decode this incredibly complex, sort of deformed light signal that comes back.
Okay.
And they can do it now with such fine-tuned accuracy, they can analyze the pattern of the vibration.
So it's like a sound signature.
Precisely. They can easily tell the difference between, say, the low rumble of a heavy truck rolling by or the sharp single sound of a manhole cover being opened.
Yeah.
But most importantly, they can isolate the very specific sound wave from a tiny, otherwise inaudible leak under the street.
So even a trickle of water makes a sound the fiber can hear.
A very specific high-frequency acoustic signature, and the fiber cable right next to it picks it up.
Wow. So Orange's main infrastructure for internet data is now also a city utility protector. How much cable are we talking about here?
This is the genius part. They're leveraging their existing 700,000 kilometers of buried lines. They're not inventing a new sensor. They're turning what's already there into, as they call them, subterranean sentinels.
Instead of digging up the city all over again.
Right. And while fiber sensing isn't brand new, it's been used for a decade in remote places like pipelines in the desert. This is the first time it's really viable for a dense, noisy urban environment.
Because the sensors and the algorithms are finally fast enough to process all that data in real time.
Exactly. And the people at Orange see this opening the door to, hundreds of possible use cases. Once you have these ears under the city, you can do things like vehicle counting, traffic management. The fiber becomes the eye and ear of smart cities.
That is an amazing use of something that's already in the ground. Okay, so let's come up from under the pavement now and look at our cars. We found a story about a breakthrough in electric vehicles that could mean, well, the end of conventional brakes.
Yeah, this is some seriously disruptive tech coming from Mercedes and their subsidiary, YASA.
And it all starts with the motor itself.
It does. It's a YASA axial flux motor. And for years, engineers have talked about putting motors right at the wheels, but the idea never really took off because they were just too heavy.
Right, too bulky.
YASA changes all that with just record-setting power density.
Give us the specs on that. What are we looking at?
Okay, get this. The motor weighs 12.7 kilograms, just under 30 pounds, and it produces over 1,000 horsepower. That power-to-weight ratio is just off the charts. It's possible because of the axial flux design, which is just inherently more compact and efficient than the radial motors you find in most EVs.
And this power density is what ties into braking. We know all EVs have regenerative braking. The motor slows the car down and recharges the battery a bit. Yep. But we're talking about getting rid of the physical brakes entirely, at least on the back wheels.
Yeah.
That sounds a little terrifying.
It's the goal, and it really comes down to trusting the tech. The YASA motor has such a huge capacity for regeneration. It can convert so much of that forward motion back into electricity that it could actually handle all the braking needed for the rear axle.
So you're turning stopping, which is just wasted energy, into like an absolute energy recovery system.
Exactly. And if you zoom out a bit, the benefits are huge. It means better efficiency, which could mean much longer range. Or maybe more importantly, they could use a smaller, lighter, cheaper battery to get the same range.
But the weight savings seem to be the real headline here. How much are we talking?
It's genuinely astonishing. They're saying gains of up to 200 kilograms on current EV models just by taking out the rear brakes, the calipers, the heavy discs, all of that.
200 kilos.
But on a car designed from scratch around these motors, where you could also get rid of things like drive shafts and differentials, the savings could be up to 500 kilograms.
500. That's like taking 3 adults out of the car. It must completely change how the car performs, how it handles.
It changes everything. The car's lighter, it's more agile, needs less energy. Simon Odling at YASA talks about the incredible architectural freedom this gives engineers. You're not just saving weight, you're freeing up a huge amount of space.
It's an engineer's dream, then. Every kilo you save lets you improve everything else. The aerodynamics, the suspension, the battery placement. You can rethink the entire car. Okay, now for our third topic. And honestly, here's where it gets really interesting. We're moving from physical engineering to the limits of intelligence itself. We're looking at the fundamental flaws of generative AI. And this is happening despite its insane adoption rate. We're talking 800 million weekly users. Half of all students are using it.
And the sources really emphasize a core truth that everyone using these tools has to understand. It's not a mind. It's a statistical machine.
What does that actually mean, though?
It means that whether you're using a language model like Mistral or an image generator, the process is the same. It's been trained on a massive, massive data set, and its only job is to statistically predict the most sensible next thing, the next word, or the next pixel. It doesn't understand the world.
And that lack of understanding leads to these, I guess, glitches in logic. The experiment in the source is just brilliant, asking an AI to draw a skyscraper next to a slide trombone to compare their sizes.
And the result you get is almost always just nonsense, right? It's the perfect example of this limitation. The model knows what a skyscraper looks like, and it knows what a trombone looks like. It's seen thousands of pictures of both.
But never together.
Exactly, because why would it? So when you ask it to compare them, it has no statistical basis to do that. It has no internal real-world concept of scale or physics.
So it just kind of mashes the two images together in a way that looks plausible statistically, even if it's physically impossible, like a trombone taller than a building.
Right. It's not a failure of drawing. It's a failure of modeling the world.
And this same lack of logic pops up in text, too, where you'd really expect it to do better.
This raises an important question, right? What happens when you try to force it to be logical? The sources talk about this test using the date 1776 and a technique called chain of thought, which forces the AI to show its work step by step.
And what happened?
Well, it did the math perfectly. It correctly figured out that 1776 is divisible by 4, not a centennial year, so it is, without question, a leap year. It shows all the right steps.
Okay.
But then, after all that correct logic, its final conclusion is that the establishment day was in a normal year.
So it contradicts its own findings.
Precisely. It's a statistical glitch. It shows that even when it seems to be following rules, the final output is still just its best statistical guess, which can be plain wrong. It's a master of recognizing patterns, not a master of logic.
And that matters so much now, because AIs are writing almost as many articles online as humans are, which is why you, the listener, shouldn't be surprised when you see things online that just feel off or nonsensical. You're hitting the limits of the machine. So what does this all mean? We've gone from, physics turning fiber cables into underground ears to engineering that's making cars hundreds of kilos lighter, and then to computation revealing its own statistical limits. It's a real convergence of forces that are shaping our world in ways we don't always see.
It really highlights how important critical thinking is becoming. We're all using these incredibly powerful new tools, but we have to remember they're built on statistical prediction, not logical understanding. Recognizing that difference, that it's predicting what's plausible, not what's true, is just crucial.
It makes you wonder, as more and more of the content we consume is AI generated, if you, the listener, will start to develop a sense for it. If you'll be able to spot the statistical glitches in a news article just as easily as you can see that a picture of a giant trombone next to a skyscraper is just ridiculous. Yeah. Something to think about. This has been a deep dive on Le Podcast de Philippe. We hope you enjoy the deep dive. Help us to reach 2,000 subscribers and share our podcast.